Hey everyone. So clearly I haven't noticed the board yet, but I was really excited to think about doing these next two short videos. Well, one of them is going to be short and one of them is going to be a little longer. This is Chapter 6, Assignment 9 in class. It's actually an AP free response question from 2003, problem number 4. Comes with a graph. Our graph looks like a little graph. So we've got this linear part, and then we have a semicircle. Okay, this is -2. This is -3, 1. This is 0, -2. There's our y-axis. This over here is 4, -2. And this place is 2, 0. Okay. This, we're told, by the way, this is no calculator. And the graph is labeled, this is f prime. Okay, this is a graph of f prime. So here we go. Let f be the function defined on the closed interval from -3 to 4, with f of 0 equals 3. The graph of f prime, the derivative of f, consists of one line segment and a semicircle, as shown above. A. On what intervals, if any, is f increasing? Justify your answer. Well, this is not a graph of f. So we're not gonna say from 0 to 2, f is increasing, because this is not a graph of f. This is f prime. F is the antiderivative of this. But wait, I'm asked to figure out on what intervals is f increasing, and this is f prime. Look at your f prime sign chart. F prime is positive from -3 to -2, and has a 0 at -2, and then f prime is -0, negative. So I'm going to put 0 here, negative. And I guess I want undefined. So, yeah. Oh no. Negative to 2. There we go. And here I have a value of 0 on that part. Okay, so when is f increasing? F is increasing on -3 to -2 because f prime is greater than 0 on -3 to -2. Okay? Remember, understand what you're looking at before you start reading the questions. They went to the trouble of telling us twice here in this problem that this was a graph of f prime, not a graph of f. So use f prime to help you figure out when f is increasing. And we learned in chapter 5 that when a derivative was positive, the function, the antiderivative, would be increasing. Okay, part B. Part B says find the x-coordinate for each point of inflection on the open interval from -3 to +4. Notice it's an open interval. Most American students have a tough time understanding that you can't have an inflection point at an endpoint. And as a result, a College Board often sets us up in this situation where we can just ignore the endpoints. That's why that's there. So, where are the points of inflection? Well, points of inflection occur when f double prime is 0 or undefined, and that means the slopes of f. Wait, so we want f double prime equal to 0, which means the slopes of f prime equal to 0. So that's a negative slope, that's a positive slope, a 0 slope. The slopes of f prime are equal to 0. So great, I know at x equals 2. But couldn't we also have f double prime undefined as a place where we would have a point of inflection? Well, there's an undefined slope. This is actually an undefined slope, but we're not including the endpoint. But I do want to include x equals 0 and x equals 0. Now, I'm asked to justify that. I will by saying, you know, we were thinking about this by using f double prime. But I don't see a picture of f double prime here. And it seems that often in the last few years, College Board has said we gave them f prime, we want them to use f prime in their justification of these inflection points. So I'm going to say that f has inflection points at x equals 0 and x equals 2 because f prime goes from decreasing to increasing or increasing to decreasing at those points. You know, you might think about in turning this into two sentences, one for the inflection point on f at 0, where f prime goes from decreasing to increasing, period, and then there's another inflection point on f at x equals 2 because f prime goes from increasing to decreasing and split into two. I think this is sufficient. We do have a little more freedom with inflection points rather than mins and maxes. So I think with mins and maxes we're not okay with this. We would have to split into those two different sentences. But with inflection points, this is fine. Okay, part C. Find the equation of the line tangent to the graph of f at 0, 3. Not this. We're not trying to make this tangent line at 3. No, 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 no. We want to have the tangent line on the antiderivative function, on f at the ordered pair, on f at 0, 3. So what information do we need to write the equation of the tangent line? Well, we need a point, but we also need a slope, and that's called f prime of 0. What is f prime of 0? Well, it's the y value on this graph. This is the f prime graph. And at 0, f prime is negative 2. And so my tangent line, y minus 3, is negative 2, x minus 0. And you can certainly stop there. We're just asked for the equation of the tangent line. If you really need to, you could take it further to negative 2x plus 3 equals y. But otherwise, no. Stop. Just be done and move on. Okay? Just always go back to that basic understanding. Oh, a tangent line, what do I need? I need a point. Ooh, they gave it to me. Yay. And I need a slope. And a synonym for slope in our class is derivative. So I need the slope of f at 0, and that's called f prime of 0. And since this is the f prime graph, we know that the slope is this y value on f prime. Okay, and then the last one, find f of 3 and f of 4. Okay, now this is your FTC2 question. So I want to say that f of 4 minus f of 0 equals the integral from 0 to 4 of this f prime graph. Right? This is FTC2. If I integrate f prime, I go back and evaluate the antiderivative at those endpoints. And we were given f of 0, weren't we? That's right. F of 0 we were told was equal to 3. That's what this was. So I'm going to plug a 3 in here. So to me, in order to find f of 4, I've got to add 3 to the value of the integral from 0 to 4. Okay, so f of 4 equals 3 plus the integral from 0 to 4 of f prime dx. So now how do I find that integral? Well, that integral from 0 to 4 is represented by this stuff. And what do I see? Well, I am so not going to try and integrate that circle again. Oh my goodness. I had so much difficulty with that when I inadvertently tried to do that in the video for 10 in class review. Oof. So instead, what I'm going to say here is, I'm going to appeal to the geometry of the situation. I've got this rectangle, and I'm going to take this semicircle away from the rectangle. So that's going to be 3 plus the area of the rectangle minus the area of the semicircle. Okay? So what can we say about this area here? Well, this area, this rectangle, has a width of a length of 4 and a height of -2. So -2 times 4 is -8. Now I'm going to subtract from that the area of this semicircle. Okay, so what can we say about the area of that semicircle? Well, I think about pi radius. So the radius is 2. I'm going 2 in all directions. So 2 squared. That's the whole circle. We only want half. 4 pi divided by 2 is 2 pi. Okay, so I'm looking at 2 pi. Now, I like that. That's good. I gotta get this. So I know that. Oh yeah. Okay, sorry. I'm subtracting this, and this is below the x-axis, so I'm subtracting that. Right. It's always tough on my brain. So I'm going to end up with 3 minus 8 minus a minus, and there's f of 4. Okay, watch out for your signs. Good. Now, what about f of -3? Well, f of -3 actually has us integrating backwards. F of 4, we were going this way and accumulating area as we went this way. Now we want to find f of -3. And just with that same FTC setup, I could do something like this. However, this has me integrating from 0 to -3. And that's really hard on my brain, even harder than this. So what I'm going to do is pull out that negative and flip these to go -3 to 0. All right. So what was f of 0 again? Remember, f of 0 was 3. And again, if I want to find f of -3, I can add 3 to this integral. Oh, it's minus the integral -3 to 0 of f prime dx. Okay, well, let's do this part now. If I integrate from -3 to -2, I'm going to have this triangle. At -3, I have a y value of 1, and this distance is 1. And so I know that this area is 1/2 1 times 1, or 1/2. Now, what about this area? Well, it's still a triangle. This distance is -2. Actually, I'm going to call that distance 2, because I'm going from here to here. But this is -2. And so my area of this triangle is going to be 1/2 2 times -2, or -2. So what's this integral? Well, that's going to be 3 minus 1/2 minus 2. Minus 2 or minus 2? Hold on a second. This is minus 2. Yes, I'm going to say I'm adding those two together. That's going to be negative 1.5 times a negative is positive 1.5 plus 3. 3 plus 1.5 is 4.5. And so I should end up here with f of negative 3 equals 4.5. Now, let's try out a little experiment, just, to sort of confirm this number. Here's what I'm thinking. I'm thinking that if f is 4.5 here, this area, 1/2, brings this number up to 5, right? So I was at 4.5, I added a half, now I'm at 5 by the time I get here. As I go from negative 2 to 0 with all this, we're saying, okay, I was at 5, and now I want to go 2 away from that. So 5 minus 2 is 3. And so when I get to 0, f of 0 has to be 3. Right. Okay. This question, find f of negative 3, find f of 4. Yeah, almost every single year for the last 2 decades, you can count on a question like that. All right, well, so there you go, and 15 minutes for the whole thing. We came in at 1640 with me slowly teaching our way through it. So don't worry, we'll do a whole bunch of those, and you'll be able to get more comfortable with them. Take care. See you in the next video.